Hello and welcome to Technology Update. On today's show, we learn how to cut through solid granite like a hot knife through butter, how a design classic still has room for improvement, and how to recycle tyres and improve roads in one fell swoop. But first, we're all familiar with the lengthy security procedures at airports, but we recently found out that the technology that keeps us all safe can also be used to put a smile on a girl's face. Tech. Diamonds are prized the world over for their astounding physical properties and dazzling aesthetics. They're also a girl's best friend, or so the song goes. And no matter whether you're the Queen of England with her crown jewels, or you prefer something more subtle, one thing is true. The larger the diamond, the rarer it is, and the more it's worth. That's why Russian diamond producer Alrosa struck up an unlikely partnership with a company specialising in explosive detectors. Neutron Technologies is located a 2-hour drive and a leisurely bike ride outside of Moscow in the tranquil town of Dubna. The town doesn't look much like a scientific hub, but appearances can be deceiving. We've come to the Joint Institute for Nuclear Research. The institute currently unites 18 countries and has 7 labs carrying out pioneering research in particle physics. And this is where the magic happens. Hidden away behind these radiation-proof doors lies a hive of innovation and the home of Neutron Technologies, which was founded in part by the Nuclear Research Institute. The explosive and narcotics detectors produced here are used in airports, train stations, as well as by the Russian security services. One of their latest developments is this mobile detector for use in the field. The device can identify the chemical makeup of any object located in anything from a cardboard box to up to 30 centimeters of solid concrete, all of which is thanks to the compact neutron emitter inside.
This is the heart of our unit, the neutron accelerator. It's only 30 centimeters tall and weighs only 8 kilograms, which is a dramatic reduction compared to last century's accelerators, which were 6 stories tall, yet it generates the same number of neutrons, 50 million per second. And on top of that, it has a built-in alpha detector, which allows us to track the tagged beams. So you see how much progress has been made thanks to the research and development of the past 15 years.
The main components of the device are the neutron generator, alpha detector, tritium target and gamma detector. The device works by emitting deuteron particles. When the deuteron hits the tritium, the beam is split into alpha and neutron particles. The neutrons penetrate the object in question, while the alpha detector is responsible for determining the location of any dangerous substances. The neutrons excite the nuclei of the atoms they hit, causing them to give off gamma rays, which are then picked up by the detectors. The energy of the gamma rays is unique to each element, which allows the substance to be determined based on its elemental composition. This method offers many advantages over X-rays, which can misidentify substances, and gas detectors, which don't work with sealed objects. The laser grid on the front of the detector corresponds with the neutron beams, allowing the user to target the object. Our computer then processes the information received by the detector and identifies any potentially hazardous materials and their location. In addition to the mobile detector, the company has designed a device for inspecting vehicles, another for shipping containers, and an underwater device for examining unexploded torpedoes and mines. All of the detectors can identify up to 30 types of explosives and be operated at a safe distance, while a computer program takes care of the number crunching to get to the bottom of the matter.
This unit has been set up to see whether we can detect a large, valuable diamond within a lump of kimberlite without having to crush it first. If there was a large diamond and the ore was ground down first, the way it usually is, the shattered diamond loses a lot of its value. So if we were able to detect large, valuable diamonds in the ore, it would offer a really good return on investment, since such large diamonds are quite rare and very lucrative.
Following the request from Alrosa, the scientists set up this rig to see if their technology could be applied to the diamond industry. Alrosa then sent 50 kilograms of kimberlite rock samples, which is the best source of primary diamonds, for the company to try out its detection system. After hours of testing, Neutron Technologies finally struck gold. Sorry, diamond. The next step is for the detector to be upscaled so it can pick out the rocks containing larger diamonds on the conveyor before they're destroyed.
We did indeed find diamonds inside the ore, and we're planning to continue testing this method next year. and then to make improvements to the detecting device in cooperation with Neutron technologies. We're planning to use this method for the detection of large diamonds in the kimberlite extracted from the Mir and Internationalny mines. We'll be focusing on the largest size segment, 5 carats and above.
Now, the theory of using this technology has been proven. Alrosa needs to consider the practical side of implementing it on an industrial scale. If Neutron technologies can reduce the time it takes to detect diamonds, I'm sure the companies will have a bright future together. Not only will it lead to increased profits for Alrosa and open up a whole new market for Neutron technologies, but also put a smile on the face of many a girl. The Earth is a place of wonder and beauty, with its rolling hills and lush forests. And as you've just seen, there are many treasures hidden out of reach, but you don't always need explosives to get at them.
Brains over brawn.
Oil, the liquid gold that makes the world go round. Without it, we would grind to a slow and painful halt. Fortunately, oil supplies aren't depleted quite yet, but the bad news is that easily extractable sources are running out. So with demand for oil higher than ever, engineers have been forced to look for new ways to get at the black stuff and keep the world spinning on its axis. Oil and gas deposits can be located under anything from layers of sand and clay to solid rocks like granite and basalt. So oil companies need a drill that can make short work of anything that gets in its way. There are currently 3 main types of drill bit. The tricone drill, which is made up of 3 spiked rollers, the fixed cutter, which often has diamond edges and works by scraping away at the rock below, and the turbo drill, which spins much faster than the other 2 and requires less downward force. Unfortunately, diamonds aren't forever and all the drill bits wear out and have to be replaced, which can be both costly and time-consuming. This, combined with the increasingly complex nature of drilling, means that traditional methods are being pushed to their limits. The Institute of High Technology Physics in Tomsk has a laboratory that specialises in blasting through solid rock with high-power electrical sparks. The first experiments were conducted way back in the 60s when the theory of using electrical pulses to drill through rocks was tested. The results were impressive, but the technology at the time did not allow for the idea to be taken further. Now the university has a prototype device that offers many advantages over traditional drilling methods.
The
advantage of the high-voltage electric impulse method is that we use bore bits made of ordinary steel. We don't use any alloy grades or diamonds. Our spark discharge method makes these very expensive materials redundant.
And this is how it works. A generator produces the electricity, which is then stored in the capacitors and fed to the drill. The drill bit itself has 1 electrode in the centre, surrounded by an array of other electrodes. When they come into contact with the rock, the potential difference between them creates a powerful spark, which travels through the rock, acting like a micro-explosion, causing bits to break away. The debris is then carried back to the surface with a liquid pump. The size of the borings can be controlled by adjusting the distance between the electrodes. The drill's ability to make short work of solid rocks has even drawn attention from companies abroad.
Norwegian companies like Statoil, the tunnel construction firm Mesta, Unodrill from the University of Trondheim, have supported our work in developing this new technology. We have supplied them with a submersible high-voltage impulse generator with which to drill an experimental well in granite rock so that we can investigate the potential of this technology in the field. Our device is of great interest to tunnel engineers and, of course, great interest to oil companies. The potential of mechanical drilling methods, be they either with diamond heads or with roller bits, has been almost fully exhausted. And this is why every company is now looking for a new method, a new technology, to ensure a fast boring speed, especially through hard rocks like granite.
The drilling speed is determined by the size of the rock fragments produced, so in general the bigger the better. However, if the borings become too large, the pump system may have trouble removing them from the hole. But by controlling the energy produced by the generator, the distance between the electrodes and frequency of the electric pulses, the optimum speed can be achieved. So who knows, if more major oil players see the benefits of this technology, we may soon have the bright sparks in Tom's to thank for keeping the world in motion.